Bismillahirrahmanirrahim. Hi everyone. 7.3 is about thin lenses. Thin lens is defined as a transparent material with two spherical refracting surfaces whose thickness is thin compared to the radii of curvature of the two refracting surfaces. There are two types of lens. First one is convex, converging lens, and the second one is concave or diverging lens. A lens has two spherical surfaces with radii of curvature R1 and R2, where R1 and R2 are represent the radius of curvature. O is the center of the lens, where all rays pass through this point will continue in a straight line, while the horizontal dotted line is a principal axis, where it is aligned through the center of curvature C1 and C2. In actuality, there are two focal points for every lens, the same distance from the lens on opposite sides. The distance from the lens to the focal point is called the focal length. For converging lens, the focal length is always positive, while diverging lens always have negative focal length. Before we sketch the ray diagram, let me introduce you the important part for convex lens. Here, we have a principal axis. F represents the focal point, where it is a distance of one focal length from the lens, and 2F is twice far away. So, by the end of this video, hopefully you should be able to draw the ray diagram to locate the image for any place that we were to put the object. So we have tree here as an object.
Then the object distance from the center of the lens. First we have U greater than 2F, U equals to 2F, in between 2F and F, and U equals to F, and lastly U less than F. So where will the image located, as we have the variation of U here?
Before we start to sketch the ray diagram, I want you to prepare a paper, a pencil color, and a ruler. Okay, done? Alright, okay, good. So let's start to find the image together. Okay, the first one we have U greater than 2F. Remember, U is represent the distance between the object to the lens. Okay, this is a convex lens. And you can try to use F equals to 2 cm and 2F equals to 4 cm, while the object is equals to 6 cm. Okay, done? Good. Alright, so first we draw a parallel ray that enters the lens, where this line is exactly parallel to the principal axis. When it comes out of the lens, it is refracted or bent in such a way that it goes through the focal point. It must go through this F point. Okay, it cannot be just some random point or some bent line. Okay, good. Next. Okay, ray 2 enters the lens going from the object through the focal point. As the line strikes the center of the lens and comes out a parallel line. So these lines are parallel to the principal axis. And the third one. So the last line So this ray, we draw just a straight line through the center, and the image is going to be located where those light rays converge. So there will be our image. As you can see from this diagram, as the image is opposite to the object, so it is real, inverted, diminished, and located in between of F and 2F. Okay, so how is it? Is it okay? So hopefully you are still with me, because we are going to draw for the second one where the object is located at U equals to 2F. Okay, just like the first one, we need to draw 3-ray diagram, where the first one is a parallel line, okay, passing through the center, and it will refracted or bend to the focal point. And the second one, the yellow line, okay, passing through F and going to be a parallel line. And the last one, it is a straight line, okay, passing through the center of the lens. So what will be the image form? It will be real, inverted, same size, and opposite to the object. Now we move to the third one, where U is located in between of F and 2F. Okay, for this object, I want you to draw the 3-ray diagram first, and from the intersection of the ray diagram, state the characteristic of the image, and we will compare our answer together. Are you done, kids? Do you have all the 3 lines? Okay, so now we have the intersection of the ray diagram. So this is our V, where V is the image distance. So we can see from this diagram, the image is obviously inverted, real, magnified,
and located opposite side to the object. You get the same answer? Good.
Alright, the next one will be a little different bit, but still we are going to apply the same steps. Now the object located at F, coming near to the lens. So we have our F and 2F. So what will be the first line? Okay, so just the same with the other. The first ray parallel to the principal axis and bend towards F. For the second one, we cannot draw the second line since the object is at F. So we draw the third one, passing straight through the center of the lens. So you will notice these two light rays are parallel, and parallel light rays do not intersect even we extrapolate it at the back side. So no intersection, you guess it, no image. So what can we say is the image are at infinity, same side with the object. It is at the same side with the object. Okay. So yeah, the last one where U is less than F. Okay. So coming here to the lens. So what will be the image for? So we sketch these two lines and we will see the intersection at the same side with the object. So the object would be magnified, upright. Since it is upright, means the image is visual. So for the case of U less than F, the image form is magnified, upright, visual, and at the same side of the object. Okay, that's all for convex lens.
Alright, this is our first diagram for concave lens where it is located in between of F and 2F. So let's draw the first line that is parallel to the principal axis passing through the lens. And since this is a concave lens or diverging lens, means the light rays will be refracted and diverge. So what will be the angle for this bending light rays or this refracted light rays? Is it any specific angles? Okay, so there is no specific angle. So as we know that the light is refracted when we pass through the lens, so these bending light are coming from the F, from the same side of the lens as the object.
We draw the second line as it enters the lens as if it was going to F on the other side, but when it comes out, it goes parallel to its axis. And the third one we draw goes right through the center, as we draw the same thing for convex lens. It goes right to the center and the light ray will not refracted or bending. So as you can see here, the intersection for these three lines, it will produce a diminished image where this image at the same side as the object, so that it is visual and upright. For concave lens, I'm not going to sketch the ray diagram for the 5 different locations of object, because the characteristics of the image form for concave lens are always visual, upright, diminished, and between lens and f1. Alright, now we will look at the thin lens formula, lens maker equation, and the linear magnification. So firstly, 1 over f equals to 1 over u plus 1 over v. This is a thin lens formula. Ku is represent the object distance and v is represent the image distance. Don't forget to consider the positive value of f for convex lens and negative value of f for diverging lens. Okay. Linear magnification is defined as the ratio between image height to the object height, where m is equals to hi over ho equals to negative v over u. Okay, are you still with me, guys? Okay, this is the last one, lens maker equation, where it is equals to 1 over f equals to n material over n medium minus 1 times to 1 over r1 minus 1 over r2, where r1 is the radius of curvature for the first refracting surface and r2 is the radius of curvature for the second refracting surface. So we have two types of lens, which is converging and diverging. So you need to know the types of the converging lens and the diverging lens. So you don't need to remember whether R1 is positive or R2 is negative.
Okay, so how to know whether R1 or R2 is positive or negative? So what you need to do is assign or let your eyes to be at the left side. And let's look at the first example. The first one is by convex, where it has R1 as positive and R2 as negative. So from the left side, R1 is the convex lens with the positive focal length. So R1 is positive. And when you look at the second refracting surface, R2 will have a negative focal length, thus R2 is negative. So that is how you know whether R1 or R2 sign.
Okay, this is the summary for the sign convention for thin lens. You need to understand well the quantity for thin lens U, V, R, F and M, and also HI and HO. Other than that, you need to remember RIVU, real inverted virtual upright. And don't forget to take note that for flat surface, R equals to infinity. Okay guys, that's all for topic lesson 7.3. I hope you enjoy and really understand for this topic, because this topic is really interesting and we have been used this lens in our daily life, such as spectacles, simple camera, magnifier and microscope and many more. Okay, bye. Assalamualaikum.